Well, welcome back, fifth graders. We are now on part 2, and we're going to start on page 409 so you can follow along. We're going to just start reading at the very top with because. So here we go. Because astronomers still believe this theory about how our planets formed, they had a problem with Pluto. When it was first discovered in 1930, astronomers assumed Pluto was made of ice and gas because of its great distance from the sun. However, by 1987, Pluto had moved into a position that only occurs twice in its 248-year orbit, and scientific instruments had improved. Astronomers were able to study Pluto and the light that reflected off it. Their instruments told them that Pluto was dense and must have a rocky core. The new information raised questions. If the planets closest to the sun were rocky and the planets farthest away from the sun were mostly made of gas, why was Pluto, the most distant planet of all, made of rock? Then right here, we have a diagram as a text feature with a couple captions. So let's go ahead and read those. It says Earth is a terrestrial planet, which means it has a solid inner core. And then the second one here is telling us, though they are made almost entirely of layers of gas, Jupiter and other gas giants have a small solid core. So this text feature is giving us additional information that really helps us understand the differences between the terrestrial planets, the gas giants, and where exactly Pluto fits in with that. It also shows and names the layers of planets, which we should be really familiar with because we almost finished that Earth history unit. So we have the crust and the mantle, and it shows where each of those are located in relation to each other. It also shows the type of gases present in a gas giant, and it also shows that Earth has a liquid outer core surrounding the solid inner core. So let's see here. You have a few questions that I think you can answer now on your Google slide. So let's look at what you could answer. One is here, what caused astronomers to have a problem with Pluto? So why were they thinking it wasn't a planet, or why it maybe should not be a planet? So go ahead and you can answer that. We'll talk about that during Zoom. We also have, you might need to reread to find the answer to this, but to fill out this chart, which planets are terrestrial and which are those gas giants? And I believe that is the only questions you can answer. So, well, nope, that's not true. We've got right here. So how does the diagram on 410 help you understand the text? So you can go ahead and type in an answer there. And I think this one goes back to that previous page, which is according to theory, why are some planets mostly made of gas and others made of rock? So I might have to go back and reread to figure out why that happens. And that would be on page 408. You would find that answer. All right, so let's go ahead and go to page 410 and start reading. All right, you can start at the top with me. It starts with there. So there were a lot of other questions as well. Pluto's orbit is different from the orbits of the planets. Think of an orbit as a lane on a racetrack. Just as runners have their own lanes on the track, each planet has its own orbit around the sun. For the runners, all the lanes together make up the racetrack. For the planets, all their orbits taken together make up the orbital plane. Just as runners don't run outside their individual lanes, planets don't travel around the sun outside their individual orbits, except for Pluto. Pluto crosses Neptune's orbit. So then we have this text feature here. We've got a diagram or an illustration showing us some things. And then we've got the caption, which is going to tell us what it's showing it. So let's go ahead and read that. All the planets, comets, and asteroids in the solar system are in orbit around the sun. Their orbits line up with each other, creating an imaginary flat disk called the orbital plane. Pluto's orbit, which takes 248 Earth years to complete, brings it outside the orbital plane. For 20 years of each orbit, Pluto moves inside the orbit of Neptune, making Neptune farther from the sun than Pluto. Pluto is inside Neptune's orbit from 1979 to 1999. So when I read that, there's a lot of information on that page. So I want to make sure I understand that. So it tells me that the text or that the orbit is like a lane on a racetrack. So I think about how they're similar with what they're showing me. And as I kept reading, I can see that each planet also has its own path around the sun. And I also picture if I was running in a race and I was staying in my lane, what it might be like if I were to cross lanes or see someone cross lanes. And this is how I picture Pluto. Pluto crossing that lane into Neptune's. Okay, so now I know there's another reason that Pluto is a little bit different. Okay, let's go ahead. We're going to go to page 411, and we're going to start at the top there. It says the shape of Pluto's orbit is different too. The larger planets travel around the sun in an oval-shaped orbit. Pluto's orbit is more of a stretched out oblong. The other planets' orbits are level with the sun. Pluto's is tilted. Comets' orbits are often tilted, so astronomers wondered, could Pluto be a comet? And of course, there is Pluto's size. Astronomers knew Pluto was tiny when it was discovered in 1930, but because it was so far away, it was hard to see the planet clearly. Pluto appeared as a tiny dot of light in the night sky. Then telescopes improved. Oh, right here, I'm getting to some of those answers when I was asking those initial questions when I started to read. What changed and how did it change? So now I'm seeing they couldn't see Pluto very well, and now it's moved closer, and now telescopes have gotten better. So now they're going to be able to take a really close look at Pluto. So let's keep reading to see what happens. Okay, in 1976, American astronomer James Christie discovered that the tiny dot everyone thought was Pluto was really two objects. Pluto had a moon called Charon. Once astronomers discovered that Charon was separate from Pluto, they realized that Pluto was even smaller than they had originally thought. Pluto is only 1,440 miles in diameter, so we know that goes through the center of Pluto. Charon's diameter is 790 miles. They began to ask, is Pluto too small to be a planet? And since they found Charon, they wondered, were there more objects out there the size of Pluto? Were they planets too? Okay, so a couple things. Just to go back to 410, just to make sure that we're understanding that text feature and also make sure we're understanding the differences of what or how Pluto is compared to other planets, I'm going to ask you that question. And that question is, how does this help you understand how Pluto is different and how planets move around the solar system? So go ahead and pause, and then you can unpause to check your thinking. All right, my thinking was that Pluto's orbit is tilted and more oblong, unlike the other planets. The orbit also crosses paths with Neptune's orbit. These differences suggest that Pluto might not be a planet. One other thing you can do here is, in your Google slide, we've got some more cause and effect for our text structure. So why was Pluto hard to see, and what happened as a result of telescopes improving? So here it's a little bit different. They're giving us the effect first, what happened. But we need to figure out what caused that to happen. And the what happened was Pluto was hard to see. What caused that to happen? So we're going to go ahead and type that in. This is something we'll talk about during that Zoom session. And then over here, they're giving us the cause. Telescopes were invented. What was the effect of that? Telescopes were invented, so what happened? So you can answer those two questions. And then we're going to go back to our literature anthology. All right, we are now on page 412. And let's start at the top. It says, in 1992, astronomers made an amazing discovery. 9.3 billion miles away from our sun is another region of space shaped like a disk. Astronomers believed it contains approximately 70,000 icy objects, including Pluto. This area of space was named the Kuiper Belt after the Dutch-American astronomer Gerard Kuiper, who lived from 1905 to 1973. In 1951, more than 40 years before its discovery, Kuiper actually predicted that a region like this might exist. Michael Brown, Chad Trujillo, and David Rabinowitz are planetary astronomers who study Kuiper Belt objects, or KBOs. People often call these men the planet finders. Together, they hunt for planets at the outer edges of our solar system using the Samuel Oschin telescope at the Palomar Universe Observatory in California. The Oschin telescope is a wide-field telescope, which means it views broad regions of the sky at once. When paired with a camera at the observatory, it can take pictures of these large areas. In the past, astronomers had to spend their evenings peering through telescopes in order to study the night sky. Now things have changed. Well, I'm coming back to that question again. Things have been changing. Robots control the Oschin telescope and its cameras. In the evenings, the cameras in the telescope at the Palomar Observatory are at work. They take 3 photographs over 3 hours of the part of the sky that the men want to study. Any objects moving across the background of billions of stars and galaxies will be captured in pictures. The pictures are then sent from the telescope's camera to the bank of 10 computers at the California Institute of Technology. Next, the computers decide which objects appear to be moving and therefore might be a planet. Usually, the computers select about 100 objects. When the men arrive at work each morning, the pictures are ready for them to view. Okay, so the first thing, when I'm reading the 4th paragraph, it says that robots change the way astronomers study the night sky. I start to wonder again, how did things change? As I continue reading, I find out that astronomers no longer have to stay up at night and watch the sky, that robots are taking pictures all night long, and then they're uploading them to computers, and those computers are analyzing that information. And then when the astronomers come in the morning, they can study that information. Okay, you have a slide I think you can answer. Let's check. Here it is. So it says reread the first and second paragraphs on page 412. What is the Kuiper belt? So you'll give me just a paraphrase of what that is, and then we'll discuss that when we are in a Zoom session. All right, we do have one more text feature here, and it says objects in the Kuiper belt are so far away, it takes them hundreds of Earth years to orbit the sun. I like this because it's giving us additional information. It's not expanding on any information we've had in the text. So we have, I'm going to ask you one more question to pause. So I want you to study the photo on 413 with that caption I just read. How does it add to that information in the text on page 412? So how does that caption and that picture add to the information? So it's given us new information, but how does it add to it? What additional things is it letting you know about this text? So go ahead and pause and then click back on to check your information or check your thinking. All right, my thinking was the photo and caption, it helps me visualize the Kuiper belt because it's giving me a really clear picture of it and understand how difficult it is to locate a planet within that region, because look at all of what's in that region. All of those tiny dots are things that they are trying to track to see if it could possibly be a planet. Okay. I'm going to go ahead and stop here. We're going to pick up on part 3 on page 414.